Why, yes, yes, I am. Welcome to the next to last panel. And yes, I do know the Warriors will be playing shortly, and so we'll not take up too much of your time and try to make this as entertaining as possible. My name is Vaughn Nichols. I've been covering technology since I think before many of you were born. And before that, I was a happy sysadmin and programmer for NASA back in the 70s and 80s. So in brief, I know a wee bit about what I'm talking about, but the people on my left know far more than I do, and they'll be much more interesting. I will let them introduce themselves to you, starting on my immediate left with...
Sure. So my name is Alex Crawford. I work for CoreOS, and I head up the container Linux team over there. So we're responsible for actually maintaining the Linux distribution itself, in addition to all of the tools and applications that we need in order to test, build, and maintain the operating system going forward.
Great. My name is Aparna, Sinha, and I lead product management at Google for Kubernetes and our hosted offering, Google Container Engine. I'm also part of the Kubernetes open source community as one of the PM leads for the PM SIG.
I'm Brendan Burns. I run Azure's container service. And I was also one of the co-founders of the Kubernetes project and continue to be heavily involved in both its development and ongoing leadership.
Okay, and our topic for the day is Linux and Kubernetes, security in a two-distribution world. And by that, what we're talking about here is, as I'm sure you've all noticed, Kubernetes, like Linux before it, and then OpenStack in the middle, has become distributized. We now have, just off the top of my head, I can think Red Hat has its own Kubernetes, Canonical, SUSE, Mirantis just jumped in a couple of weeks ago. So we're sort of seem to be refollowing a very familiar trail, and I was wondering what you three thought about this.
I can start. I guess I have a microphone. But I think that it's a sign of maturity. I think that I don't know how many people remember, but we took a ton of flack early on about how hard it was to install a Kubernetes cluster, and I think that the degree to which people are creating distributions is a sign that people are solving that problem, and therefore people are now able to more easily use Kubernetes on their own infrastructure or via a cloud provider, and ultimately I think that's a good thing. It does bring some challenges, but I think ultimately that's a really good thing and a sign of maturity.
Yeah, I agree with what Brendan said, and I thought it was actually an interesting topic that you phrased it as a two-distribution world. It made me think about Kubernetes. I think Kubernetes is like an operating system, and that's why a lot of operating system vendors they're attracted to it, and they start to offer Kubernetes distributions. Kubernetes is like an operating system for a distributed compute environment, much like Linux is an operating system for a specific machine, whether it's a VM or a dedicated machine. So I think there's those synergies, and it makes sense for OS vendors to come in and as the level of differentiation gets raised to the next level, which is in a distributed environment at the Kubernetes level, it's a natural fit for OS vendors to come in and have distributions.
Again, I agree with everything that's just been said, but I will add, I think it will be interesting going forward in the future to see if we can keep the Kubernetes project itself very centered and avoid the forks and the sort of splits that we've seen in Linux distributions. We have vastly different Linux distributions today. It would be a shame if Kubernetes ended up in that direction, but so far what we've seen today is people very much are on board with shipping the open source, keeping all of the source open and shared and kind of aligned to the same direction.
Okay. Yeah, and I would say actually I would maybe underplay the forks of Linux distros a little bit in the sense that they are sort of different and they have different skills. But honestly, I don't think I've ever run across an application that wouldn't run across all of them, right? Maybe a little bit hard to install, but but you could make it work. I don't know, maybe you have.
Well, I was just going to bring up NixOS, but I don't know if anyone has
No,
used
but I mean, if you have a
NixOS.
binary, right? If you have a binary and you can compile that binary, it'll run, right?
For the most part.
Yeah.
Yeah.
So, and I think that there's efforts, I mean, and I think we're seeing this, like efforts like the Linux standards base that were really instrumental actually in making sure that these sorts of things were true, right? As well as, I mean, I think you get into all sorts of complicated issues around some of the drivers and things like that as well, right? Some of the proprietary source code stuff that happened with some drivers early on that sort of more or less got sorted through as people on the hardware side became more and more comfortable with open source.
And I don't think we need to make a one-to-one analogy between Linux and Kubernetes. I mean, I think looking back at Linux, yes, there are many distributions. It's not necessarily a bad thing. If you look at the different distributions, they're kind of targeted at different use cases. Some of them, you know, at the desktop environment, some of them, you know, at the more enterprise kind of lower tier, but then and then enterprise sort of heavier applications. And that may happen. Or may not happen with Kubernetes, we don't know. One thing that's worked out well, I suppose, in Linux is that there is an upstream and there is a set of standards, and as Brendan is saying, applications are largely portable between the distributions. I think that as a Kubernetes community, we definitely have to work on, and we are actively working on, making sure that there is interoperability, and there's a whole work stream around Kubernetes conformance, making sure that from a user perspective, regardless of where you're running your applications, if it's a Kubernetes distribution, it's it looks the same from the application perspective. So that's very important. And then on the upstream, it's much more neutral, and standards are emerging certainly as far as networking and now storage, and I think also other aspects standards will emerge.
Actually, to sort of follow up with that specifically of you, Alex, since you're sort of in a unique position. I mean, you've got container Linux under your preview. At the same time, CoreOS has made it very clear over the last couple of days that Kubernetes is the future. It's the meta layer which will unite all, and we will all sing hallelujah, and life will be grand. So you've got, from your perspective as someone who's, very hands-on with both Linux and Kubernetes, how do you see that working out?
Over the past few years, it has been an interesting shift in focus. Initially, our company was very much focused on creating a new Linux distribution that was able to automatically update itself. And I think it's kind of it's funny to look back, and it's kind of a testament to, okay, we did that already. What can we automatically update next? And that is Kubernetes, and that's what we're doing with our Tectonic products and everything else. And they're rapidly approaching the same level of automatic updates and security that we have in the operating system. So it's on one hand, it's kind of nice to be out of the limelight and be able to hide on the side. But it's also very exciting to watch and see these other teams start to learn from everything we've done before and really start to build a powerful platform.
Okay. And now, I guess for all of you, you sort of touched on this earlier about how so far there seems to be sort of a unity in the Kubernetes community that we haven't necessarily seen. You've been sort of downplaying the differences between the Linux distribution. So for certainly technically, if I can get something to run on Red Hat or CentOS, one way or the other, I'm going to get it to run on Debian and Ubuntu. But now if you were to ask, say, someone at Red Hat what they thought about Canonical and vice versa, then things get, well, if you know these companies, it gets rather vicious and bloody very quickly. Do you see that as a concern, as a worry for, or is that, do you really think that there's enough unity in the idea of Kubernetes that it will overcome the sort of difficulties we've seen first in Linux, and then to some extent we've seen that in the OpenStack community as well?
Well, I mean, I think that those are about products, right? Like, those discussions are about products. They're not about Linux.
Right.
Right? It's not like Ubuntu is saying, like, oh, you know what, you shouldn't use Linux. They're talking about, they're talking about different, and I think that that's always, I mean, inevitably that's going to happen. As long as there are people who are building competitive products, they're going to try and argue for why theirs is better. But I think that if you went and talked to the people from Ubuntu who contribute to the kernel and the people from Red Hat who contribute to the kernel, I expect that they work quite well together. And I think that that's, so I don't think that that has much to do with the distribution as much as it has to do with the business of building a competitive product, right?
Okay.
Yeah, I don't know that we know what the future will hold,
Sure.
and certainly from a business perspective, there could be and there may be competition. I think that that the market sort of plays out based on what users need, and Kubernetes is written in a way that it can be adapted to many different environments. I think that several of the companies that are involved in the community are adapting Kubernetes to different environments, whether it's different clouds or different on-premise environments. And depending on which of those environments sort of grow more, there's going to be more demand for that and probably more competition. So, and then companies will try and differentiate against each other where they can, and probably that layer of differentiation will shift up from above the OS and potentially above the installation piece of Kubernetes, which is right now, it's kind of, you're right, there are many distributions, and that's because the installation isn't standardized, but that might become standardized, and then the level of competition will rise. And in general, that's good for users.
Okay, now, at the same time, though, we've got this Kubernetes, of course, is another layer of abstraction above the cloud, above the containers, and so on. So from it does say security up there, so we should address that as well. At this higher level of abstractions, what do you see? Are there any significant security concerns here that we're so happy about the idea of Kubernetes, we've been sort of overlooking this?
Yeah, I mean, I think there's a couple different things. I think one thing that comes up a lot is that people sometimes forget that running two containers on a machine is very akin to giving two different people SSH access to that machine.
Yep.
And if you don't trust those two people to operate safely with each other on the same machine, you probably shouldn't allow them both to run containers. I think we talk a lot about isolation and container as an atomic packaging unit, and people start believing that isolation is about security when really it's about runtime. So I think that's a risk. I think there's been a lot of talk in the press about basically how a hypervisor is really the only truly secure barrier you can have, and I think that's mostly penetrated. But I think that's probably the biggest risk that I would have. But I think that benefits far outweigh that risk. So.
Okay.
I think there are different levels of security problems in a containerized world. They're certainly at the OS level, and I think we are seeing an evolution with CoreOS and with other container-optimized operating systems that the operating system is becoming, for the node itself, is becoming very minimal. That, of course, lets the node start faster, but it also makes it more secure. And then it's becoming something that can be managed and upgraded automatically and patched automatically. And I think over time, the expectation with containers is that developers and cluster admins will not need to manage the operating system and will not need to worry about the security of the operating system. So that's one level, the node operating system. Then the other levels, as Brendan started talking about, is on the containers itself. There's multiple levels of security problems potentially there, because containers enable you to pack many more workloads much more efficiently onto the same infrastructure. And so there needs to be isolation, and there needs to be capability for setting policies and preventing different workloads from interfering with each other and different workloads from seeing each other. And there's a lot of work in the Kubernetes project to ensure that, to enable greater multi-tenancy and multiple workloads to run on the same cluster. And that has to do with ensuring that pods have identity, that nodes have identity, that users are using role-based access control instead of attribute-based access control. Those are some of the primitives that we're building in. And of course, there's the underlying primitives with namespaces and C groups, and then things like SE Linux and Aparna that allow you to specify exactly what a pod can consume or what an application can consume. And then there's service-to-service communication at the network level as well. And so there's work on each of these pieces to enable a more secure way to run your applications in a sea of distributed resources using containers. And I think that is is really maturing over the next year, I think we will see that it'll become much more, I guess, more like the way containers run in Borg, or the way that they run at Google, but just much more efficiently the way that it's I think containers can enable.
To touch a little bit on what I think Brendan had started saying was, I think one of the other major risks today, and I think this will change in the future, but today I think one of the major risks comes around complexity. We have a very new project like Kubernetes. We already have a fairly complex kernel underneath. The Go runtime, there are so many moving pieces that I think it's right now, until people get really comfortable using this and truly understand the scope of changes they're making, there are pitfalls that exist that it's right now it is easy to fall into. And I think a lot of the work that CoreOS is doing around operators helps that. If we can prescribe a method for performing operations and codify that, and just ask the user to press a button, or run a script, it becomes a bit more reproducible, and we can at least avoid areas that we know to be problematic.
Yeah, just to riff on that a little bit, I think that we are still in a world of building bespoke distributed systems, like hand-built. I'd say it's like the Portland. We're all living in Portland and building artisanal distributed systems. And that means they're more brittle. That means that we forget about things. It means we don't have standardization. I think what we're going to see is this movement towards operators and other forms of canonical ways of running pieces of your distributed system that will enable us to really focus on all aspects from reliability and security and centralize our effort and therefore make it much, much better. The security people, you might not be a security person, you might be a reliability or ease of use person, and you're going to focus on that. Someone else will come along because you can collaborate and make that piece more secure, make that operator more secure. I think that's a huge thing that this transition is enabling, but we're not there yet.
Okay. Of course, eventually for end users, this will all be magic. It will just work. I mean, isn't that really the idea here, is just to make containerization as just mindlessly simple for them all. But as all these comments are making really clear, behind the scenes where you are working, where we're all working, it's actually a very complex project with indeed many moving parts. I mean, what's it like trying to manage that? Because again, you've got, besides just the Kubernetes layer, you've got all these other layers beneath you, and they're all spinning. I mean, how do you manage a project like that, security like that?
Yeah, that's a very good question. So from my day-to-day roles, I am responsible for our operating system. I'm not directly responsible for our Kubernetes distribution. However, I work very closely with the people who are, and oftentimes we find, as much as we try to decouple these systems, we find points that they are coupled together, and there are sometimes cases where we have an issue in our version of Kubernetes, which requires us to fix something in the operating system, and just because of that alone, it dramatically increases the time that it takes to fix these things. Now, fortunately, we have the ability to automatically update operating systems overnight, so we're able to pull all of that back and still reasonably update people quickly. But it is definitely a challenge. From the kernel alone, we watch a number of different sources for reportings of security issues. There's public mailing lists, and then there's embargoed mailing lists, and we're watching these constantly. And I'm sure the Kubernetes team is doing the exact same. And every now and then, we have something that overlaps, and we just have to coordinate and make sure that we get A, B, C done before everything is secure again.
Yeah, I mean, I think that in any of these systems, the whole goal is to decouple everything, right? That's the only way you can deal with it, right? Is I'm going to trust, hopefully, the kernel people to do their kernel thing, and I'm going to do application in Kubernetes level security, and then I'm going to trust the developer to build a secure application on top of the container orchestrator. But sometimes there are these links, and then eventually, sometimes it turns out that somebody's running a web server inside your CPU, right? And Intel, for the last 10 years, has done this, and it turns out that it had an issue, right? So, like, I think that at some level, I mean, I think Kelsey said this at one point, that security is a journey, not a destination, right? Like, you're never going to every once in a while, you're going to have to go on that giant bug hunt where you get everybody together. And if anything, this is a testament to the value and strength of open source, because it means that we can have all these communities come together. We don't have to worry about lines quite as much. We can have these embargo lists that go everywhere. I think that if anything, is one of the major strengths of open source.
Yeah, no, I agree. I think from a Google perspective, we're very dedicated to open source and to carrying pure Kubernetes in Google Cloud. I think at least I consider myself fortunate because there's a lot of history of operating systems development and maintenance within Google Cloud. So that gives us some history both on kind of how to manage security vulnerabilities on the operating system side and run the service. The other is that we listen a lot to customers, and we have on Google Container Engine sort of a guiding light in that form in terms of guiding the roadmap. On the open source community side, I think your question of how do you manage the product, so my role is more on the product management, open source SIG, and I think that it is definitely difficult. It's definitely complicated. It's not specific to security, but what tends to happen is that there are many different SIGs, and they are contributing and moving along in their own sort of SIG-specific roadmap, and often there are features that don't necessarily work well together. And so one of the roles of the PM group is to find those types of features and highlight them and get the SIGs to sort of look at the dependencies between each of and we don't always do a good job of it. I think we had an issue with RBAC and KubeADM in the last release, and so we do, and that's part of the reason why the SIG exists and part of what we try and get done. The other piece that we try to do is make sure that there's good documentation and that we are taking the user perspective in writing the documentation as opposed to the engineering perspective. So there's a lot of community work that goes into trying to make the project run. And this is just from the PM side. There's a lot more on the engineering side as well in terms of code health and the repository and so forth. So those are some of the challenges of running a project of this size, which are, they may have security implications, but it's not only security related. This is just managing open source.
Sure. Actually, going back to a comment you made about the bug hunts, there will always be bug hunts no matter what we do. But are there any, in Linux there, of course, there's a whole system of CVEs, and you referred to some of the mailing list, public and restricted. And of course, Kubernetes has its own CVE system. Are there any particular major differences between how the two different groups handle CVEs, or anything big, bad?
I don't think
Unsurprising?
I don't think so. I don't think there are any major differences that I know of anyway. Yeah, I don't know if I have anything else other than no. There's
Okay.
Maybe do you have thoughts?
No, there's no real differences I can think of. Kubernetes has had the opportunity to look at what works and what doesn't for the past, several decades, and they went with what worked.
Okay.
I will say one of the interesting things is that the vulnerabilities are different in the sense that the vulnerabilities that we see primarily are through our API, right? Through our API server. They're not bugs in the kernel where somebody does a memory exploit or that remote code execution, that sort of thing. It's much more about flaws in how we've implemented the API that we deliver to the end user, and that's a little bit of a difference, I think, in the two systems. It actually makes it a little bit easier to check. Because the class of bugs that exist are not as significant, as well as the fact that things like Go, you pointed to the Go runtime being unknown, and it's true, but actually Go protects you against a lot of the sort of common exploits that people have against binaries, buffer overruns and that sort of thing. So
Yeah, no, but I think that point around the vulnerabilities are different is very important, because again, like working in a container orchestrated environment is different, and so that's why we're building in, a roadmap for Kubernetes. But the other point of vulnerability is in the actual images, and what's your source of trust. And so that's another area of, I would say, active development to make sure that you scan the images, that there's a source of trust, that there's an audit log, so you can go back. There's BCID. So there's a number of different initiatives around making sure that images are trustworthy, making sure the system can't be penetrated, and then of course at the OS level, certainly CVs, but also just other mechanisms for isolation at the OS level.
Okay. You know, over in the Linux universe, of course, there are things like AppArmor and SE Linux to help nail down everything. Do you foresee us seeing anything like that happening in the Kubernetes universe?
I mean, well, we already have things like that, right? I mean, network security policy is one aspect of that. So there's stuff that happens in a distributed system that a single operating system maybe isn't thinking about as much, like connectivity between different applications.
Sure.
As well as I think we're going to see people build things on top. You're starting to see, you know, things like Linkerd and other sorts of systems that are being built on top to provide application level, sort of automatic application level security, where you can say like this user can only talk, you know, this application can only talk to these other applications, and it has to use TLS and things like that. I do think this is an area where there's going to be a great deal of standardization that allows people to just sort of do the right thing out of the box. I think there's, you sort of pointed out to image provenance. You can do things in Kubernetes like say, hey, I'd only want to admit images from this particular repository, right? I only want to take things from my private repo. I don't want to take things from, you know, all of these other places. There's a lot more we can do there, but you're starting to see the bits and pieces that allow people to create systems that check for problems before the user even knows that there's a problem there. So I think it's a little different than what AppArmor does, which is more sort of like block you. That's more like the RBAC that's already in Kubernetes.
Right.
But there's a lot more that you can do to actually effectively prevent people even from bringing in applications that have problems anyway.
Do you see that sort of thing being built into Kubernetes itself or being built on top of it?
Both. I mean, I hope mostly on top. My goal in general is everything should be built on top. I think you mentioned distributions and things like that.
Right.
We're reaching a place where I think the API is mostly done, and although we've been saying that for a while, although I've been really strongly believing that for a while, and people just keep sort of creeping things in. And so I hope that most things will be built at least as extensions to begin with, and then maybe brought into the core. I think there's some things like RBAC that just has to be in the core,
Sure.
right? But I think a lot of these sort of admission controllers and even systems like, you could imagine building a system that scraped across all of the services that you're running in the cluster and then ran XSS detection against that service and looked for vulnerable web pages and things like that. Like that's something you can easily build on top, deploy to the cluster once, and then have that available for every single thing that gets deployed to the cluster. So I think there will be a lot of these kinds of security services that deploy on top.
Yeah, I'm not sure that I know what the clean demarcation is between these pieces that are going to be in Kubernetes versus outside of Kubernetes. Certainly like the service-to-service authentication and service-to-service policy work that would be part of Spiffy or part of Linkerd. There are many implementations of that, and that's outside of Kubernetes, but works very well with Kubernetes. RBAC, of course, is within, and setting, giving the node identity, giving the pod identity. Those are things that are going to be, I think, within Kubernetes, depending on what your definition of core versus not is. Yeah, and then certainly image provenance. I mean, that's not part of Kubernetes, but it's very much linked to how you would use services in a Kubernetes system.
Actually, I think the mention of the admission controller is actually one of great interest. When you have a single standalone operating system, you're concerned about the applications that get run on this.
Right.
But now that we've taken this step up to the cluster, now we also have to worry about the nodes that are joining our cluster. If you have your data center and I walk in with my special box and I plug it in, you really don't want me to go in and start accepting work and manipulating credit card data on your behalf. I'm usually a trustworthy guy, but not my hardware. And the question of admission controllers, I think, is something that CoreOS is definitely exploring with remote attestation and being able to do trusted boot and secure boot. And I think that's an area that we're going to see OS vendors start to really step into to differentiate themselves in this space.
Makes sense to me that they would.
And I think in clouds as well, I would say. Right?
Yeah.
Things like TPM chips and things like that.
Another question I have here on my list. In Linux, of course, you have, speaking of core, we've got the Linux core, and then, of course, we have all the stuff that happens in user space. User space, of course, is a little bit more prone to trouble, shall we say. How do you see that playing out in a Kubernetes universe?
Yeah, I think it's a really interesting question. I mean, user spaces may be prone to trouble, but on the other hand, there are efforts like the Linux standards base that sort of try and help describe what user space should be like. I think that we're going to see something similar. I mean, I think there's a lot of arguments as people build extensions. Like one of my favorite examples is this cube Lego thing that automatically lets encrypt certs for you. Automatically creates them, pushes them onto your certificates, or excuse me, onto your services. It's so useful that I believe that these kinds of things are going to be things that people simply expect, right? They simply expect them to work. But will they ever be something that we would call the core? Probably not, right? I'm not sure I ever want to pull that thing into the core. And so we're going to have, I think, layers of conformance or layers of sort of application expectation that says like, hey, you know what? This is the baseline, but there's this extended application profile where, you know, this class of applications will work, and then maybe even beyond that. I think that that's going to be an important part of what we figure out as we go forward. It's not there yet, though, for sure.
Okay. Switching to another topic, Kubernetes, actually, so many new things in the container world has put on a new vision of package management. And in the Linux world itself, we're seeing all kinds of different approaches, new approaches besides the traditional debs and RPMs to package management. How do you see that playing out in the Kubernetes universe?
I think there's a couple different things. One is immutable deployment, right? I think at this point we have decided immutable deployment is the only way to deploy things.
Right.
And that's a huge difference because suddenly you don't really have to worry about, like a lot of what apt and yum do is about in-place upgrade, is about how do you run a script and clean up and ... And so I think that the kinds of things you need to do change, but I think that then the thing that happened was distributed systems suddenly meant application configuration and application topology and application rollout actually becomes important, right? So the sort of stuff that you're doing in the operating system to run scripts and lay down different files has suddenly moved up to the cluster where you're, doing a rollout across a service or connecting, one layer to another layer. So I think there's similarities and even dependencies, right? Like if you look at Helm and you deploy something like Ghost, well, it understands that it needs a MySQL, and it goes and it deploys a MySQL, and then it deploys Ghost on top of that MySQL. So I think there's a lot of similarities, but there's also these differences that happen sort of where the rubber hits the road. I don't know.
Yeah, I think package management at the Linux level is less applicable to the new world, but there's certainly add-ons that you want to add to your vanilla Kubernetes cluster, and certainly services that you'd want to pick. And you want to make sure are trusted services, and set policies around who can access which services, and have a model for scaling services. And so, there are many different, certainly PaaSes that have been built on top of Kubernetes to, provide that kind of construct for users. And Kubernetes is very amenable to building PaaSes, but also some underlying pieces which the community is standardizing on, like the Open Services Broker and the Service Catalog, the Service Broker API, which allows you to plug in and build service brokers for different services. And just sort of consume them in your cluster. And then the work with service-to-service communication enables you better security and authentication for that. So that's how you bring in different services into your cluster in a trustable, policy-based way.
Okay. Anything to add, or?
I don't have too much to add here. I think they hit all the points for me.
Okay.
Sorry, I have one last thing, which is, in my experience, installing stuff on a Linux OS almost never gives you a ready-to-run system. And I think as we've thought about cloud, and I think as we've thought about, we have focused more. There's been an increased focus on deploying things that are secure by default, that are distributed and ready to run from the ground up. So I think that's an important thing. I think that's a really good thing. It's no longer like, hey, look, I used apt to install MySQL, and then I learned a lot about the config file, and I figured out how to actually turn it into something that I can use. there's a lot more notion that it should just work once you deploy that Helm chart. So that's a good thing, I think, for people.
Speaking as a former sysadmin, I agree completely. Got really tired of config files over the years. That's it for my questions, but we have a few minutes left. Do we have any questions out there from the audience? Oh, you're all being so quiet. Oh, there we go. I knew there'd be at least one.
Awesome. So GRSec in Linux. So basically, there's forces between proper upstream Linux, like vanilla style, and then folks who are slightly more paranoid. What's your view on the sort of the average paranoia and the tinfoil hat plus what was it? Special tape that Redbeard had. What's your view on both Linux kernel and container Linux, and consuming GRSec? And then, is there going to be a similar sort of, instead of alpha and stable, will there be a paranoid thread for Kubernetes?
So I think the tinfoil hat is very good, and you should all regularly wear those when it comes to running infrastructure.
Redbeard is very proud of you.
From a container Linux perspective, speaking of GRSec specifically, I don't know if you saw in the news recently, but they've made efforts to close that a little bit and make it a bit more proprietary, which does complicate things a bit. We're trying to figure out legally what that means for the GPL and that sort of stuff. As to your question about whether or not we'd have a tinfoil channel, probably not. We would prefer everyone have the tinfoil hat always, and that's why we've pushed on trusted boot, and we're working on secure boot, and all of these technologies and security mechanisms that we're putting in place. We want everyone to use these and use these by default, and that means making it easily available and easy to use, because like those config files, if it's difficult to set up or confusing or error prone, people are just going to opt to not to use it at all, and that's exactly what we do not want.
I think in Kubernetes, we don't have channels as such, but we have our version of that with the evolution of different parts of the API. We have an alpha, label on things that are unfinished, that are just getting started, that are totally try at your own risk, and then beta, which is much more getting closer to stable. The API has, for the most part, been locked down, and then stable, which is has been in use for quite some time, and we're pretty confident about it. So we have that. These aren't different channels, but these are designations for parts of the system. And then I think in actual practice, when users are running services on a cluster, and when it comes to Helm charts and other deployment managers, there will be here are the trusted services that have been tested and certified, and then here are the experimental ones, or here's ones that you can try at your own risk. So I think that will exist.
I think also in that sense, one of the I think probably the earliest pluggability efforts was around the container runtime and making sure that you could plug in different container runtimes into Kubernetes, and I think that's also a place where people who wear tinfoil hats may make different choices. Hypervisor-based container runtimes or otherwise, and so having that be a choice that people can make is a good one, and ultimately probably something that a distribution may make for you. You may have the tinfoil hat version of distribution of Linux that makes specific choices around the container runtime and how it's configured.
Do we have time for any more questions? I guess we do. Go for it.
So you said that we're really tired of config files. What do you see as their replacement?
Config map. No, I think if you've looked at the work that has gone into representing config as a Kubernetes object, I think that's that, and then that combined with the way that it's reflected through the downward API into your containers, that's the right way to start thinking about it. The trouble is, of course, the MySQL config's not going away, so we have to figure out, and people are working on ways to sort of bridge between the two worlds. Kelsey Hightower had this etcd to config file bridge that he built a while ago. There's a lot of efforts there, but that's I think the right approach. In particular, it's hard to do rollout across config files, and it's hard to have multiple config files per like a canary beta release if you don't separate them into separate API objects and do a late binding.
Thank you.
Anyone else? Going once, going twice. Thank you very much, all of you. I think the panelists were all wonderful, and I was happy to help them get their word out. And at this point, I guess we will say goodbye. I'm sure if you have any specific questions for folks, you can track us down. We're easy to find. Thank you.